Good evening, guys. Welcome back to my channel. So today we are gonna discuss about the Kubernetes concepts. In my last class, I've discussed about the what is Kubernetes architecture, pod, replica set, and deployment. So we have discussed about the Kubernetes architecture. In my last video, if you guys have seen, what are the components present in master node? What are the components present in worker node? What does this API server does? How it is act as a front door, etcd act as a database, scheduler will take care of a responsibility of scheduling a pod and a node, and this control manager makes sure whatever the value that is stored in etcd, the desired value, and what is the current value, it compares and it spin up the new pods based on the desired value if something goes wrong with the existing pod. So kubelet, this is the one who is going to initiate and run the image and convert into the container, and kube proxy, this is related to networking side area. Okay, this is how your node looks like, and a cluster, multiple nodes. So I've explained like front door, API server, etcd is a key database, key value format, it stores scheduler pod and a node, control manager based on the desired state. Okay, kubelet stops and start the containers as instructed. Okay, kube proxy with regards to network rules. So what will happen in the backend when you do kubectl apply -f? So as soon as you apply this command, so in the backend, what is happening? This API server records the desired state. What is there? The desired state in the etcd, which is the database. The scheduler picks a node. What the scheduler will do to schedule a pod on a particular node. Kubelet on that node pulls the image and start the container. So scheduler does a job of what? Bring up a node where the pod has to schedule and pulls the image and starts the container with the help of kubelet. This is what we have discussed in our last session about a detailed discussion about pod, replica set, and deployment. If any application is going to, any deployment is going to happen on a particular pod, for example, if the deployment happen on this particular pod, if this pod goes down, what will happen? There's a downtime for application, correct? So that's why the deployment will happen on a replica set, not on an individual pod. Replica set is a combination of multiple pods. So if something goes wrong with one pod, the scheduler and the etcd and controller, all these things will comes together and take care of it and schedule a new pod. So controller will take care of the desired value and spin up the new pod as per the process. So you know what is a pod, right? Smallest deployable unit. What is a replica set? It's an identical pod based on the replicas you have been requested for deployment. So deployment, managing a replica. Deployment basically happen on what? On replica set, not on a pod. Just remember that. Now, core concepts of Kubernetes namespace. So you need to understand what is a namespace, what is a daemon set, what is a stateful set, what is a config map, what is a secret. So these are the core concepts of Kubernetes, which we are going to discuss along with ingress, persistent volume, liveness and readiness. Is the application ready? Is the application ready to accept the traffic or not? HPAA. So these are the very important concepts which we are going to discuss now. So what is this namespace? A virtual cluster inside a cluster, used to isolate teams and environment. Development, staging, and production namespaces on a same clusters. So namespace for each environment. Okay. Now, what is a daemon set? Ensure exactly one copy of a pod runs on every selected node. Ensure exactly one copy of a pod runs on every node. So you are having a pod which is running on each and every different node, running a long shipper example, Fluentd on every node. So this is an example of an application is giving. So if you have clear on this two things, okay, what is a namespace? Namespace is a virtual cluster inside a cluster used to isolate teams or environment. So inside a cluster, So what is happening here is inside the cluster. So you just need to focus on inside a cluster used to isolate teams or environment. Now, inside a cluster, you'll be having a multiple environments. Number one, development. I'm just highlighting because so that you can go with me. Staging and production, which means in the cluster, you have a three different environments. Correct. You have a staging, you have a prod, development, staging, and prod inside the same cluster. Okay. Right. What is a daemon set? Ensure exactly one copy of a pod runs on every node. Ensure exactly one copy of a pod runs on every node. So daemon set is kind of basically a background process which makes sure one copy of a pod runs on every node. This is what is very important, not on a single node. It's not talking about a specific node. It's talking about every node. You have to consider this one is important. Control B, Control V, and then this. Okay. Running a long shipper example, Fluentd on every node. So this is a kind of an example which has been given here. Now, what is a stateful set? Manage pods that need stable network identity and persistent storage. Stable network identity, strong network. That's the basic meaning of that. And persistent storage, which means even in case of a restart, it should not lose the data. Okay, that's the meaning of persistent. The data should be recorded with respect to volume, recorded to the volume, the container and the volume, where you attach a pod to the volume. Even after any restart, your data is the same, irrespective of a container ID. So that's what the basic things comes into the picture. Again, as we discussed, deployment happened on a replica set, whereas a stateful set is managing a multiple pods with regards for a strong networking and a persistent storage. Deploy MySQL or Kafka cluster. This is an example. Okay. So just to make sure to correlate with a real-time environment. What is a config map? See, config map stores a non-sensitive information, non-sensitive configuration data as a key value pair. So this is what important, non-sensitive configuration data, which means this is important and it still can be in a readable format and it should not be visible in the code and stored in somewhere else. So you have a separate config map and you're calling that config map. That's all. Applications log level or future flag settings. Now next, what is a secret? Now stores sensitive data. See, this is what the difference between a config map and secret. I hope you understand. Config map is something having a non-sensitive data and this one is having some sensitive data. And when I say sensitive data, and this sensitive data is like your password, tokens. These are cannot be shared at all because your system and everything can be hacked. Database password used by payment services. So database password you can say. I'll highlight this one here. So what do you understand here? Within the cluster, okay, within the cluster, if you are need to have a partitions for a different environment, that will be considered as a namespace. Daemon set. Ensure exactly one copy of a pod runs on each and every node. It's kind of a backend process which is running on each and every node. What is a stateful set? Manages a pod that needs a stable, strong network, strong connectivity. What is a stateful set? Stateful set is referring to persistent storage as well, apart from the strong networking. This is one example. What is a config map? ConfigMap is referring to non-sensitive data and secret is referring to sensitive data. That's all. So both are referring to the same thing. Now, what is the next ingress? What is the ingress? Let's understand. Exposes HTTP, HTTPS routes from outside the cluster to internal services. So this is a single point of contact when the traffic is coming from outside of the world. It's not regards inside the project or inside the cluster or inside the organization. Okay. Something is coming from external world to the project, to the cluster. So all the external traffic, ingress controller is a single point of contact. Exposes HTTP routes. Exposes routes. This is what it is important. So as soon as you expose your routes from outside to the cluster to internal services, which means which are running inside the cluster or outside of the cluster, whatever it is, to access your internal environment. To access your internal services or environment, you're exposing the routes. You're exposing the routes, even if it is HTTP or HTTP secure and insecure networks from outside. Routing shop example.com to the storefront services. Like these are the examples. I hope this is clear so far. Ingress is a single point of contact for external traffic. Whoever is sending a request from outside, if they wants to connect to the internal services, has to come from routes. Okay, first exposes the routes from outside to the cluster to internal services. Now, next, persistent volume. Now, this is really important here. Persistent volume. So how you're going to store your data? Cluster-wide storage resources provisioned independently of pods. Cluster-wide. So this is what? Across the cluster. What is happening here? Cluster-wise storage resource provisioned independently of pods. And EBS, NFS volume backing a database pod. So your volume is attached to the pod. Anything happen to the pod, restart, doesn't matter because the volume is attached to the pod. That's what basically is. So your data is safe in not in pod, in the volume. You can spin up the new pod by attaching the same volume. Whatever the data was there previously, everything can be recovered. So resource provision independently of pods, which means if something goes wrong to your pod also, no need to worry about the data. That's what the achievement is. If something goes wrong with the pods, no need to worry about storage. No need to worry about data because persistent volume is there. Now, next, understand what is the liveness and readiness pro. What is this liveness and readiness? Let me highlight this. Okay. Health checks that restart unhealthy pods or hold back a traffic until it is ready. Restarting hung Java service automatically. So, health checks that restart automatically pods. So, what is happening here is liveness and readiness. So, if you understand liveness and readiness, liveness means your application is up and running fine. Your application is up and running fine, but it is not ready to accept traffic. That is liveness. Your application is up and running fine and ready to accept traffic. That's called a readiness. So health checks that restart unhealthy pods or hold back traffic until it is ready. I hope this is clear here. Liveness and readiness. Let me repeat once again. Liveness is referring to your application is healthy, up and running fine, but not ready to accept a traffic. Whereas a readiness application health and running fine, ready to accept the traffic. So example, what we are understanding here based on a one line definition is health checks that restart unhealthy pods. If your pods are unhealthy, supporting to health checks that restart. Restarting hung Java services automatically. What is HPA? Automatically scale the number of pod replicas based on CPU memory custom metrics. Automatically scale the number of pod replicas based on CPU memory. So if the traffic is huge, whatever imagine your pod are 3. You have a pod and you have a replicas as a 3, which means 3 pods is handling the traffic. And all of a sudden traffic is huge. Then in that case, this existing pod or replicas is not enough to handle the capacity. So you need to set an alert based on the CPU memory utilization or the metrics, customized metric. You have to increase the number of pods. It's as simple as that. If you have a replicas 3, then make it 6. If you have a 6, then you make it 12. If you have a 12, make it 24. In the same way, so scaling, automatically scaling. How the scaling happens automatically? The scaling happens automatically based on the current situation. If the CPU, memory, custom metrics is reaching high, then in that case, the pods or replicas has to be increased. Scaling checkout services from 3 to 10 pods during a scale. So I hope you understand in terms of ingress. What is the ingress? Exposes routes. Exposes routes from outside to the cluster. Exposes routes from outside the cluster to internal services. So you need to understand what is ingress is happening. Ingress is a first point of contact which is allowing from outside the cluster to internal services. If someone is who is making communication from outside of the cluster to internal services means that is ingress. Persistent volume. Persistent volume basically talks about storage resources. Okay. Which means your data is going to store in that storage. If something goes wrong with the pod, it doesn't matter. If you have your volume attached, persistent volume attached, then you can restore the data for an, or you can say you can spin up the data for a new pod. And you need to understand liveness and readiness. Application is up and running fine, not ready to accept traffic. That is called as the liveness. Application is up and running fine, but ready to accept the traffic. That's called readiness. So here trying to explain by giving an example. Health checks that restart unhealthy pods. Health check that restart unhealthy pods or hold back a traffic until it is ready. I hope you are clear on this. Now next coming is HPA. Horizontal pod auto scaling, and auto scaling will happen based on the current situation of CPU and memory, all those things. Resources capacity. If the resources is reaching up 80% alerts, like your CPU 80% alert, your memory 80% alert, your custom metric 80, then you have to increase the resources. When I say resources, what are those? They are pod or replica sets, or you can say and. Okay. Scaling checkout service from 3 pods to 10 pods during scaling. Okay. Now, next, ingress traffic flow. We'll see this ingress traffic, how the external user, how the route, how the service, how the pod. So before reaching a connectivity for a pod, the request is coming from services. The service is cluster IP. Then before that, ingress or route. HTTP routing rules, external user. So this is what the connectivity is talks about. Next is kubectl commands to demonstrate. So you need to basically familiar with the kubectl commands, which are really important. Kubectl get pods to see list of pods and their status. kubectl describe pod name, detailed pod info and events. So normally if you want to see only how many pods are running, then this is a command. If you want to go in detail description, then detailed pod, kubectl describe pod name. Now if you have to check the container logs, what is that you have to do? So checking container logs, kubectl logs pod. So here the command is wrong. It's like -c container name. Okay. kubectl get service SVC. Here we have to go for -c and then the CID container ID. Maybe one pod can spin multiple times. So in that case, you have a multiple container ID. So kubectl logs pod -c container ID. And if you want to list the services, kubectl get SVC, recent cluster events, kubectl get events. Liveness, CPU memory usage, kubectl top pods. Okay. So if you really want to see, if you really want to see liveness and all those things, then you have to go for kubectl top pods. If you want to see the events, kubectl get events. So like the way, in the same way, how you have understand about a Docker by using Docker commands, how you have done in terms of Git by using Git pull, Git push, Docker pull, Docker push, all those things. In the same way here, we are dealing with Kubernetes commands by using kubectl. So basically you are listing the pods and their status, detailing the pod info and events, describe pod name. If you want to see the container logs -c container ID, kubectl logs pod -c container ID. And then because if you have to see for a specific container ID, in that case you have to give a container ID here. kubectl get SVC list of services, kubectl get events, recent cluster events, kubectl top pods, live CPU memory usage, kubectl rollout status, deployment name, check rollout progress. Okay, so in this case, we are a bit familiar with respect to kubectl commands and to demonstrate. So now what is happening here? Real-time troubleshooting metrics, pod not starting. How to fix it? Check the logs, describe the pod, recent events, node not ready, verify kubelet service status and disk space on the node. Application down, check the service endpoints, whether the pods are ready or not. Next, high CPU, check HPA, horizontal pod auto scaling status, and configure a resource limit, like a request and limit. This is what it is, a resource limit is referring to. Now image pull, verify image name or tag and register the credentials. So after this, we're going to discuss about little bit OpenShift, and in my upcoming sessions, we're going to cover all these things. What to do when pod not starting, what to do when your node is not ready, what to do when your application is down, what to do when you're high CPU, what to do when image pull back off or image pull error, image pull back off, crash loop back off. So you need to very clearly understand all these concepts clearly. So you need to understand when node is not ready, what you're going to do. When the pod is going to crash loop back up or image pull back up, what you do, what could be the issue? Image pull error. So if something goes wrong with image tagging, if something goes wrong with versioning, if something goes wrong with access point of view, all these things you have to check in consideration. So, and after that, you can look into the valuable content. So I have covered all the kubectl commands and the situations issues over here. Apart from this, namespace, daemon, statefulset, configmap, secret. Okay, we have covered ingress, we have covered persistent volume, liveness, readiness, HPA, horizontal pod auto scaling. Based on a CPU and memory, it will react and create the resources. We have understand the flow before the pod, what is happening, services, before services, what is happening, ingress or route, service route. So HTTP routing rules. External user is pointing to ingress or route and then to services, route, services, and then pod. Route, services, pod. That's what you have to remember. User, route, services, pod. User, route, services, pod. This is how you need to clearly focus and read as much as you can, and so that you can remember. In the upcoming sessions, we're going to discuss about the OpenShift. So OpenShift is a little bit advanced when compared to Kubernetes. What are the scenarios? What we're gonna do? Okay, so some basic commands of OpenShift, and next is Grafana. All those things are monitoring tools we'll discuss, and will in the upcoming sessions we're gonna very clearly discuss about the concepts of OpenShift once we are clear here in Kubernetes. So in Kubernetes point of view, what I have covered is Kubernetes architecture. What are the components present in a master? What are the components present in a worker node? Okay. What are the each component is going to do? API server, etcd, controller, scheduler, etcd. Okay, and understand about pod, replica set, and deployment, and the core concepts like your namespace, daemon set, stateful, config map, secret, ingress, PV, persistent volume, liveness, readiness, HPA, horizontal pod auto, scaling. Okay, all these things. Now, next is Ingress a traffic controller. Before coming to Ingress traffic control, we have to understand the traffic is reaching at the end at the pod. So before pod, it's going to services. Before services, it has to go to route or Ingress controller, or you can say route, HTTP route, routing rules. External user. External user is pointing to HTTP routing rules. From the Ingress or route, it goes to services, route, services, and pods. kubectl basic command. If you really have to check the logs of a particular pod, kubectl logs pod. If you have to check logs of a particular container ID, then -c container ID is there. If you have to check for a services, if you have to check for events, if you have to check for pods, okay, get pods and top live, what is that capacity, all those things. Pod is not running, this is one situation. Node not ready, this is one scenario. Application down, this is a critical impact, high CPU based on a resourcing capacity. If something goes wrong with the images what have been recently built, all those things I've covered. So I hope you this video is really helpful for you to get some basic consistency and an idea. So you have to sit with a paper and pen. Try to listen to the video again and again. So that will really help you to understand the concepts very clearly. If you are a beginning for a learning of a DevOps point of view, Kubernetes point of view, Red Hat OpenShift, Grafana, Elasticsearch, Splunk, Dynatrace, how the alerts are going to configure, how to configure the alerts basically, what is happening in Grafana, what is happening in Dynatrace, how the alerts has been configured. So in my upcoming sessions, I'm gonna explain each and everything very critically. So please go through my videos. Please click on like and subscribe my channel so that I can make a quality content for you so that you can read, learn, grow. Thank you very much. Thanks for your time. Please click on like and subscribe my channel. Thank you guys. Bye-bye. Happy learning. Happy enjoying.